let's see if I can share my screen. Every time I do this, I start to wonder whether it works or not. Preview screen. Actually, I probably shouldn't be full screen so that I can actually see other people. Well, I can't see the chat. So if you want to say something, feel free to unmute and we can do that. Unless somebody with slides knows how to switch this to present now mode. There we go. Okay. So tonight I'm going to talk a little bit more about Remix and Rust and building on the edge. For those of you who didn't see the talk before, I talk a lot about how to use Rust in Remix itself, which is a pretty niche field, I guess. Pretty much the only people who are interested in this are the people who are really concerned about performance and to some degree portability. But it's been a pretty neat path getting all this sorted out. So I'm excited to talk about it some more. We're all kind of chasing performance, especially in today's interconnected lifestyle. Core Web Vitals has come out. We had a lot of talks on that at RemixConf. The idea that you need to strip off those hundreds of milliseconds, tens of milliseconds, is starting to gain a little bit of traction amongst the community. I've certainly had some problems with that in the past for some things. One of my first jobs, I did a data onboarding process that was very, very slow in JavaScript. And there's only so much leverage that you can put onto something before users will click away. You'll lose that conversion. People will stop paying attention. I think the average attention span is about 20 seconds at best, and I find these days it's a lot lower. There are a few things you can throw at people to make them more likely to stick it out. You can throw spinners, you can do skeletons, you can do a lot of neat tricks with deferring data loading and moving things around, but sometimes it just needs to be faster. Yeah, so the big idea that I presented is progressive enhancement, but an extension of progressive enhancement is that sometimes JavaScript is not fast enough, that we need to take some of the intensive compute heavy tasks that we do and make them faster by writing them in a faster language, that there's inherent ceiling that you cannot escape. And the big difference on this slide from the conf talk is I've added a little asterisk here, which we'll get into a little bit later. Sometimes this won't work out, and knowing when this can be applied is a pretty valuable tool. So quick show of hands or emojis or something in the chat. How many of you have heard of Rust? Imagine most of you at this point. Has anyone actually written any Rust amongst y'all? No? Well, you guys should, because if you, it's a great language. It is very fast. It is memory efficient. It is very reliable. It's strictly typed. If you like TypeScript, you know, this is another level of typing. And I've really gotten used to it at this point. So it's almost painful to come out of Rust sometimes. But it has a reputation for a kind of a steep learning curve that it deserves to some degree, but because it has a bit of that curve and the community acknowledges it, we have a lot of handy resources. The error messages from the compiler are extremely helpful. The community on Discord is great. So don't let that stop you from investigating it if you get the opportunity. So I've updated this slide as well because this year's Stack Overflow developer survey is out. once again, now for the 7th year in a row, Rust has topped the most loved languages. And this year, for the first year ever, it's the most wanted language. So a lot of interest in the language. A lot of people are using it, and it's starting to really show. I don't have a slide for it, but the overall usage of Rust has jumped about, I believe, 3% from last year, which is a pretty good improvement here. Everybody seems to be writing their tools in Rust, some of them for the performance benefits, some of them for the memory guarantees. If you've ever written any C, you probably run into a few malloc-free errors, some memory that you're trying to use after it's been freed. But Rust won't let you do that. The compiler prevents memory unsafety. And for that reason, and all the other ones that we talked about, pretty much everybody is talking about using it for one reason or another. But we're not here to talk purely about Rust. We're here to talk about how to use Rust with Remix. And one of the neat things about Remix and Rust on the web is that we've really kind of focused towards optimizing to make it so that you can integrate Rust without having to switch your entire platform to the language. And the two ways we typically do that are WebAssembly and native modules. WebAssembly is a compiled language that runs in a special VM that's bundled in most of the browsers now. And Rust supports it as a first-class target, which pretty much means that if you build a Rust app, most likely your Rust app can compile into WebAssembly with minimal changes, which is pretty incredible. And then there's also a native module crate that lets you interface with the Node foreign function interface. So you can call it directly from Node. And if you spent a bunch of time analyzing Node packages, a lot of the times this has been done in C. So it's nice to have a second option to hit that interface. This is kind of the path that it takes to get there. As I mentioned, these are native compile targets. So if you choose WASM, your Rust gets converted into WASM. And then we have a tool that will take it and package it up with a JavaScript wrapper to let you easily call it from your JavaScript. And it's kind of the same thing with the native path with a crate called nappy-rs. The primary difference there is that it's actually compiled Rust and not WASM, and you can call that directly. So it's just like you have a native app running on your server that you can call, which is really neat. This is the setup for it. It's pretty straightforward. For those of you who haven't seen it, Cargo is the package manager, essentially NPM. Essentially, all you have to do is install Rust, install the tool, create your project, write some code, and then pack it, and then put it on NPM. It's really easy. Here's an example Rust WASM project. Obviously not very complicated. It adds 2 numbers, but the neat thing about it is the only thing that I needed to make this WASM was this macro here. This WASM bind gen will automatically annotate this add function with all the functions that it needs to talk to JavaScript when it gets compiled without you having to think about it for the most part. And the same is pretty much true for the native modules. It's just a different macro that generates different code you can call directly. And Remix has made this pretty easy to integrate. I had to write a couple PRs to the compiler to support WASM and Node files. And unfortunately, those PRs are still not merged. But if you have those files or the patches that I wrote for it, you can use it like any other NPM package that you have. You can import it and call it and get the results, and really quite painless. In the browser is a little bit harder because WASM modules need to be loaded into memory because they don't quite support that in the browser yet, where you can call them as kind of the traditional import blank from blank method. So you have to do some kind of initialization procedure, but for the most part, you can just chunk down a use effect or edit your entry.browser and load it up and then use it. So it worked out pretty well. WASM modules are great for pretty much any computationally intensive thing, but one of the things I like to highlight are games. We've got a variety of Rust-based game engines that you can compile into. It really reminds me of the Flash days when you could write Flash and have that run in the browser, but there's lots of great movements in game development groups there. But there are other opportunities like encryption, image editing, audio processing, all sorts of things like that. And we'll look at a couple here in a minute. There are some caveats to WebAssembly or WASM. It's not quite native performance. It still runs in a VM. And you have to pass data into it and back out of it again, usually from JavaScript. And that has a cost, usually in time and memory. So WASM's usually faster than JavaScript, but not always. And the biggest way that you see this sometimes is that if you're doing something really small, like a sum or something like that, the WASM is not going to be faster than native JavaScript because it has to do that conversion into and out of WebAssembly. So don't go rewriting everything in WebAssembly or Rust just because it's faster on some conditions. Native's great if you want maximum performance. Like I said, it's like running an application on the server directly. The packages can be fairly large, so I highly recommend you don't send them to the client, but you could. And they're designed to run in a node environment. So if you're in some kind of web worker, edge worker, might not be the best choice for you. So this is the benchmark I showed at RemixConf. It's a simple hashing algorithm. It hashes a big file of SHA-256 and returns the hash. And I built it each of the three ways, right? WebAssembly, a native module written in Rust, and a pure JS implementation using SHA-256 JS. And the results pretty much speak for itself. I mean, a hashing algorithm will take a fair amount of time on a large file, and Rust is natively faster than JavaScript. So this argument here is pretty much assumed to be faster. But the interesting part of this is that it is not always faster. Like if you look at this, I hashed a 20 megabyte buffer, but the difference between these gets a lot smaller if you hash something tinier. And at some point in I believe it was around the 1 kilobyte range, it actually gets, JavaScript wins. So you got to be careful about what you use this for. So I want to talk a little bit about when you would want to rewrite something in Rust, right? Because I'm assuming for you guys, you've got your Remix backend, you've got all sorts of fun functions in there. You're not going to just write it in Rust for no reason. So these are the rules that I kind of follow. Identify the bottleneck, because you don't want to rewrite everything because not everything will have a benefit. And then why is it slow, right? Understanding that will be important because there are some tricky parts that we'll get to in a minute. And then are there any workarounds that you guys or we could use? Maybe you could cache the output or do something else like that. You don't want to put in the effort to do something that has an easier solution. And then the last couple are just, deploying Rust on a team that primarily TypeScript. Rust is a bit of a challenge, so you don't want to go off and do that without approval. But keep these rules in mind, because we're going to talk a little bit about a recent case study that I did, and I ran afoul of a couple of these. So recently I wanted to redo my developer website, as developers often do. And I need to compile Markdown. And I wanted to compile Markdown on the fly. So I didn't want to write a Markdown file and then publish the HTML and kind of do it at once. But I wanted to do it on the fly. And I need to syntax highlight all the code blocks and potentially generate a table of contents. And for those of you who have built a website like this before, usually compiling Markdown or compiling MDX into HTML is a fairly intensive process. And there are a few crates that people typically reach for. Unified Remark and Rehype Highlight, I think, are the biggest ones. There's a whole ecosystem of packages around those, but there's also Marked, which is kind of a lighter JavaScript alternative. So I went out and I took a big Markdown post and I tried to compile it and I measured how long it took and I got this output, right? So looking at this, you know, it's over 100 milliseconds for Remark and over 50 for Marked, which is somewhat slow, right? I mean, if you can get away from that, it'd be good, but it's not terrible. But since it was a case study, just continued onwards. How are we doing here? Anyone have any questions so far? Nope, okay. So workaround wise, if you remember our rules, right, there's probably several workarounds you all can think of. We could generate it and store it in HTML as a file, since Markdown typically doesn't change very often unless I'm sitting there editing the post. You know, I could cache the output, and once I've generated it, I could store HTML in the database after I've generated it. You know, there's lots of possibilities here. But I didn't really care about those. I wanted the fastest I could get. So I kind of went on here, but maybe you have a requirement that you have a Markdown editor that needs to live preview the changes the users type. Then you wouldn't be able to cache this, but something to keep in mind. If you're thinking about using Rust for this application, I mean, it's a lot easier if there's an existing Rust crate that does the work for you. And Rust has a pretty robust package system at this point, or crate system, as we tend to call them. So I found plenty of crates that could fit this bill. For Markdown highlighting, there's pull down CMark and ComRec. Syntax highlighting, there's Syntec and Tree Sitter. So thankfully, I wasn't about to go write a Markdown highlighter compiler from scratch. If you have to do that, that becomes a problem. Neither of them actually mentioned WASM compatibility or WebAssembly compatibility, you know, which doesn't always happen if it's not the primary use case. But the nice thing about all of these is that even though they didn't mention it, with a couple minor changes to one of them, I was able to get them to compile into WebAssembly. So it was really nice. And most of the crates are like that. They'll either compile or they'll compile with minimal changes. I guess I have two of these. So I built that up into a crate and I did the results again. And you can kind of see the results here. Marked and Remark are the JavaScript equivalents that we talked about last time. And then I called my new crate FeeMark. In this chart, FeeMark is the WebAssembly compiled version and FeeMark Nappy is the Node API version. So as we can see from these results, right, the native version of FeeMark is pretty much equivalent to the marked version, the lightweight JavaScript syntax highlighter compiler that we mentioned before. The WASM version was slower, admittedly, but it wasn't quite as slow as Remark. I'm not quite sure what's up with Remark. I didn't quite look into it, but it just wasn't fast. And I was kind of disappointed by these results. You would expect that, you know, I just finished telling you guys that Rust is faster than JavaScript, right? You should rewrite your things in Rust, you know, that's great. Well, it turns out that didn't quite work out for me. And it took me a little while to figure out why. And it goes back to one of the original rules that I mentioned before. So I made a classic blunder. I'm wondering if anyone has any idea why Marked would be roughly equivalent to FeeMark in speed. Does anyone have an idea? Want to shout that out?
Were they already using something similar under the hood?
You're pretty close. You're pretty close. So once I got that, I dug into what Marked does, right? And I found out that the slow points of these packages was the syntax highlighting. And the syntax highlighting uses regex. And the regex parser in Node is V8, and V8 is written in C. So as it turns out, I was actually comparing the performance of C to Rust, which is pretty much a toss-up at this point. So as I mentioned, Highlight.js uses regexes, V8s, and C. So I was pretty disappointed at this point because I'd gone through the trouble of writing my own parser for this. And best, it's a toss-up between the Rust version and the JavaScript version. How am I going to write a blog post about that? It'd just be, JavaScript is as fast as Rust. But as it turns out, I had a saving grace, and that saving grace wasn't as much about Rust, but it was enabled by Rust. See, there's a package called Tree Sitter, which does its syntax highlighting. If you guys use NeoVim, I don't know if there's any NeoVim users here, but it actually does it based on parsers and not regexes. And there's a suspicion that that might be slightly faster than the JavaScript version or the regex version. So I set out to test that next. Okay. I've lost the chart that has the things, but I'll say that it was 3 times faster than the marked version was, and I had a table for that, but we'll have to skip that. And it ended up becoming a new package on npm. I ended up publishing it as FeeMark. You all can look at it and tell me what I'm doing wrong or right. But it did turn out, so where's that old other chart? It ended up, instead of being about 50 milliseconds for compiling this thing for the marked version, it was about 12 milliseconds, which is a pretty substantial increase. And these times are all under best case conditions. They're running on my M1 Mac. I'm the only one looking at it, right? You put it under load and you put it on a smaller VM, and odds are these times will increase. So I ended up building that as a package, and I published, all those implementations and talked about it a bit on the blog if you want to check that out and tell me how I did a terrible benchmark, which I suspect I've done at this point. So my new mantra from this essentially was that a good algorithm written in a fast language will be faster than a good algorithm in JS, unless that JS is cheating. And if you've taken a look at a lot of those NPM packages, I'm trying to think of, not Lodash, but the image processing one, whose name escapes me. Most of those will either call a C library or they will call the OS itself. Like the hashing algorithm benchmark I did before this, most of them will use Node's crypto implementation, which just uses the OS and is written in C. So not always a benefit, and a lot of packages cheat. If any of you are interested in learning more about Rust, I've got plenty of good resources here. On the remix end, I've got a sample remix project with some Rust versions built into it. I've got 2 stacks with the patches for the WASM and native modules built into them, the Indie Metal stack and the Air Metal stack. I'd love it if you guys would leave a comment on my PRs to enable these things natively, so I don't have to put patches in all of my stacks. And if you're interested in learning more about Rust, the Rust book is great. Rust Adventure is Chris Biscardi's project. He's got a great series of online courses. He teaches how to build web scrapers and stuff using it, and highly recommend. But check all these out if you get the opportunity. I want to thank all the people that put in this work. Mostly I just take their stuff and bundle it in a new way. So all these people have done a ton of work to make this stuff possible. And I can't wait to see how you guys apply some of this stuff and build faster web apps with new and exciting things. And yeah, feel free to reach out to me on Twitter or however, if you have any questions, I'm around. And I'll put in a shameless plug here that if any of you are hiring, I was unfortunately recently laid off. So I'm looking for things again. So hit me up if you've got any leads on that. And yeah, I'd love to open the floor for any questions you guys have. And thanks for having me.
Woo! That was awesome. I really liked your kind of talking about this in like a very practical, pragmatic approach. Like that is such like a nice relief to hear that like mature approach. The one question I had is like I know Deno is using Rust, is like implemented with Rust. Have you looked into that at all? Does it have any like implications? Is like Rust crates like easier to work with in Deno than in Node, like bringing them in, or not really significant?
Sure. So Deno also has a foreign function interface, an FFI, but there isn't quite like NappyRS is the crate that enables you to talk to the Node API, but the support for the Deno API isn't really there yet. As far as I know, Deno doesn't really have a way to interface with Rust code other than the Rust code inside of it and the FFI. It doesn't really affect your use case. Like the Air Metal stack, which I had in the previous slide, is based on Deno, and you can use the WASM modules the same way as you could in Node, but the native implementation is somewhat lacking actually right now.
Okay, interesting.
Yeah. So I was actually really surprised to see, I mean, Deno raised a ton of money. I'm very happy for them. They launched their own framework today, I believe, fresh. I'm really excited for what they do. To go back to the slide with all the different things on it, there. The Linux kernel recently announced that their next version of the Linux kernel might have Rust actually implemented in it now instead of proposed. And I'm so happy to see all the outcomes here. So yeah. Does anyone have like a slow part of their web server or something that you think might be able to be optimized with Rust or in WebAssembly in some way?
That was going to be my question, is if you had come up with other solutions where JS couldn't cheat, so to speak, and do the same type of benchmark.
So yeah, I kind of have, right? Some of the edge worker frameworks, like Cloudflare until recently, couldn't access Node or its primitives very well. So in that instance, 90% of the time, they do support WebAssembly as a target. So if you're comparing pure JS to Rust or WebAssembly, you're going to lose or you're going to win, right? Rust is going to handily beat the market. That's one of the things that I've seen. The other place that I tend to see it is in custom implementations. I don't know how many of you have had to actually write C or C++ recently, but I don't particularly enjoy it. It's a challenge. So I'd much prefer to write that thing in Rust if I can create the same kind of NPM package output. And you're actually starting to see that in a few of the things. Prisma actually is written in Rust and compiled to an NPM package that we all love to use. OSO is as well. And I believe there's a third that's escaping me, but the idea of writing it once in Rust and then redoing it and then distributing it for JS is gaining a lot of traction, I feel. Very cool.
I have a question regarding WASM. I've never really touched it myself, but does it matter from what language you compile to Wasm performance-wise? Or would a Python to Wasm implementation have the same performance as a Rust to Wasm?
So that's a great question. And the biggest difference between a Python to Wasm or a Rust to Wasm is that Python and Go have a garbage collector. And taking that garbage collector and adding that into your Wasm has been a challenge. It usually leads to larger WebAssembly modules and somewhat reduced performance. So I haven't seen as much traction with those languages in that arena. WebAssembly modules also tend to be fairly large, like I guess it's on this chart, the FEMARC version here ended up being about 1.5 megabytes uncompressed of WASM, which is a pretty chunky package. The Rust native version on NPM is about 6 megabytes. And the JavaScript ones were like 100 or 200 kilobytes. So I haven't tried to compile it from a GC language, but I would expect it to be around twice as big. So
interesting.
Yeah. I feel like the two biggest languages right now for WebAssembly are Rust and C. Probably because they both don't have garbage compilers. But I think most people would choose Rust if they had to choose one and they didn't already know C. So yeah. Awesome. Let's see. How many of you are tracking like performance? Is performance something that you guys talk about every day in your day-to-day? As web developers, is that something that's closely tracked and monitored for regressions, or?
There's kind of that old mantra of like performance only matters when it matters, or whatever that it's only when you notice it or something like that. Well,
pretty much. I guess I agree with that. Like, I don't think most people will go, oh, this site took 200 milliseconds to load and this one took 100 milliseconds to load. I'm going to definitely not choose that 200 milliseconds. But the difference between 3 seconds and half a second, or 5 seconds and half a second, is pretty substantial.
Yeah,
so
definitely. It's like, especially you're talking about like for e-commerce or something, like you're just going to get people to just drop off at that point. Are there ways, like, how would you recommend folks just like instrumenting like that first step of identifying performance bottlenecks?
Sure. So performance metric wise, I love Henry's talk. If you haven't seen his talk, I think web page test is the service. Also metronome.sh is great for remix because it will tell you how long each of your loaders and actions will take. I believe also Sentry, if you've got that, will give you performance metrics on different routes of your page. As far as the code for like this benchmark that I did, I pretty much just inserted performance.nows in my loader before and after running different functions, which is admittedly not a great way to do it in production, but maybe you could add that to a log somewhere and then parse it. Somewhat hacky that way though. I feel like most of the time people know where the delays are going to be. It's going to be in the image conversion or the hashing of a heavy file or something like that. It's not, since this isn't faster for small, short things, you're not going to look at this and go, oh, this one database call is so slow. I'm going to put that in Rust to go faster. No, so yeah. Trying to think. Let me see what I had on that slide. I have to try now. Okay. Any other questions while I hunt for the slide?
I'm always wondering what people actually build with Rust, like apart from like the JavaScript ecosystem. Like, what's the main use case? Is this operation systems and systems, or like data pipelines when Python is getting too slow? Like, what's Rust used for mostly?
I feel like it's kind of the same use cases for C, with maybe the caveat that WebAssembly makes it a little easier to use it on the web than C. That slide with all of the companies on it, right? The Linux kernel is getting Rust. Microsoft is talking about rewriting parts of Windows in Rust. You know, all of the typical OS low-level systems language stuff. Android has it as well. And then, as you mentioned, the tools for it. But it still has a really strong base for things like CLI applications. There's some really nice tools that will let you, get arguments from your command line application and do fun things with them. There's even a Python Rust wrapper that lets you call Rust from Python. So I feel like some of those crates are starting to, or packages are starting to move in that application, in that direction, where the computationally intensive stuff is written in Rust. So I guess the answer to that generally is just wherever you care a little bit about more about performance than you do on rapidly producing code. So performance or memory safety, I should add, because Microsoft and Android all care a ton about those memory safety. Something like 70% of bugs in applications these days are memory bugs, and those are completely eliminated by the compiler, the Rust compiler. So great. Let's see what's going on in the chat. Yep, there's Henry's chat and Henry's talk. Let me see if I can. Yep. So, oops. So I did put, if you want to see how this runs and in actual action, as I mentioned, it was built for my website, and this is actually compiled without any caching in Markdown here. This is actually one of, I don't know if you've read the Faster Than Line blog, but it's an extremely long, well, this one isn't, but it's a fairly long Markdown post with a table of contents and code blocks and images and all that fun stuff. But we talk a lot about a lot of the methodology behind it, the code behind it. To go from, for example, this is the marked version here. And this is the unified version. To go from there to what is essentially 3 lines of code was really quite nice. So yeah, that's pretty much what I have for y'all. Anyone else have any questions, or how we doing? Good. Does anyone here now want to pick up the Rust book or learn Rust? Is anybody learning Rust? I'm always curious to see if that's the case. No?
Personally, this kind of gave me the nudge. I've been like hearing about Rust and only really hearing good things from people. But seeing this and like thinking about some practical use cases just for myself to like get started. Yeah, it gave me the nudge.
Go ahead.
Oh, that was it.
Oh, okay. I was gonna say kind of the 2 next things I want to put out. I think I'm gonna compare OG image generation in WebAssembly versus JavaScript, because I know we've struggled a little bit with that in terms of memory and speed. But the other thing I'm really excited about building is like an image editor that can run in both the client and the browser. Because the other neat thing about WebAssembly is that if I send that WebAssembly down to the browser, then I can build an image editor that runs near native speed in your browser itself, which is pretty remarkable. A pretty remarkable increase. So Photoshop for the web, I guess.
That would be
Great.
amazing. I've been using a lot of these like brainstorming tools or like workshopping tools like Miro at work, and it's like it is painfully slow as soon as you get like a few things on there and a few people interacting, or you want to share your screen or something like that.
Oh yeah. The I believe Prisma uses not Prisma. Figma uses WebAssembly. I'm not sure if they use Rust, but I thought I remember hearing they used WebAssembly. So yeah, great. So I don't know how you guys typically end this, but I'm happy to hang around. I want to re-extend my offer. If anyone wants to learn Rust or has questions about Rust, I would be happy to answer them and to guide you as best I can. So please reach out to me on Twitter or whatever. And yeah, I wish you happy rusting, I guess.
Awesome. Yeah. Will you be able to share the slide deck with the group as well?
Absolutely.
Awesome.
Let me put in the actual performance graph, and then I can send you the link now. I think there's a share in here somewhere, and then I'll put in the well, if I find it, I think it might be share. Private link. I want it to be public. All right, so I will put this here. Zoom's direct message thing is really clunky.
Yes.
But yeah, feel free to take a look at that. Like I said, hit up the resources, and if I can help you anyway, let me know.
Thank you so much. Yeah, this was fantastic. If anyone's got more questions, feel free to stick around. We got about 10 more minutes on the schedule, but other than that, thank you again, Ben. This was fantastic. I'll put the recording up on YouTube, link to the slides in the event. Yeah, and thank you so much.
Thank you. Have a great Tuesday.
Thank you.
Very sunny.
You were located somewhere in the Bay Area too, right? If I remember correctly.
Oh yeah, I'm in San Jose, so I'm like an hour south of San Fran.
Nice. I was really expecting you to show up with the remix jacket, supported jacket today. Kind of disappointed, to be honest.
I haven't gotten mine.
Oh, still no?
No, I don't know. Maybe I screwed up the form or something, but I'm in California. They're shipping from California. I assumed I'd be like the first one.
Right. That's
but even if I had it, probably, it is so hot. It is like 90.